Hello, this is Mr. Painter with another fabulous IXL tutorial. Today working on IXL CC.6, classify a system of equations by graphing. Alright, this is almost exactly like CC4, except the wording and terminology has changed a little bit. But graphing and determining a one solution, no solution, or infinite solutions are almost the exact same. Alright, so what we're going to do is we're going to start off by graphing the purple equation. And of course, if you need additional help beyond this video, feel free to check out the video from CC4. It's almost the exact same video. But hey, why not? Let's do a video on this one as well. All right, the first thing you're going to start with is something called the y-intercept at +5. So on the y-axis, you're going to look at 5, which is right here. So between the 4 and the 6 is your y-intercept. Now, when you have x by itself, x is the same thing as 1 over 1x. Because x times 1 is still an x. You have 1x. Which means we're going to go up 1 and to the right 1 from the y-intercept. So up 1 and to the right 1 lands right there. And we're going to go ahead and connect our 2 points by just simply clicking on them. And there we go. We got ourselves a beautiful line there. Okay, now the green equation looks very familiar. It's actually the same exact line, which takes the guesswork out. So what I'm going to do here is I'm going to go ahead and select, first of all, I'm going to select my green equation. So when you click on it, it's going to go to another set of points. And I'm going to graph it just literally right on top. And notice that you can see both the purple and the green line directly next to each other. Okay, now this is where it's a little bit different than IXL CC4. Let's talk about these definitions here. All right, first of all, the word inconsistent means no solution, okay? Inconsistent means they just don't cross, it doesn't work, right? So inconsistent means no solution. Now, consistent and independent means that they cross differently. All right, so consistent and independent, independent, that's going to be a one solution choice. And the last one, consistent and dependent, is going to be infinitely many solutions. All right, so again, this is almost exactly the same thing as CC4, except the words have changed, and I'm basically translating it for you. That's how it's going to work. All right, well, if you guys notice that both equations are the exact same, we are going to choose something called consistent and dependent because they're the same lines and infinitely many solutions. All right, there we go, rolling already. Let's start with our baby blue equation. Clear the board there. All right, we're going to start with the y-intercept of -2. So y-axis, -2, down 1, down 2 is -2. And we're going to put the negative with the numerator on the slope here. So I'm going to go down 2 more and to the right 3. Down 2 more to the right 3. 1, 2, 3 lands right here. And that's going to go ahead and give us our blue equation. Nicely done there. And if you take a look at the orange equation is the exact same thing as our blue equation. Same slope and same y-intercept. So if you can just click on top of your blue points just like that, the orange equation just got done. Now, because it's the same exact line, we're going to be looking for something called consistent and dependent. All right, so consistent and dependent because it's the same line. All right, next up we have another consistent and dependent line because y equals x. Y equals x seems so simple, but for whatever reason, it makes students struggle. So y equals, let's fill in the gaps here. We have x by itself, but wait a minute. X by itself, we have 1 over 1x, but they left out the y-intercept, so we're going to add 0 for the y-intercept. And because the blue's equation is the same, y equals 1 over 1x. So when there's no number in front of the x, we add 1. But because the y-intercept is completely left out, it's 0 because you don't have anything there. All right, so now we're going to start at 0. And we're going to go up 1 to the right 1. Now remember, slope goes forever. You can keep doing this if you want. Up 1, right 1, up 1, right 1, up 1, right 1. You get the idea, and it actually creates the line like that. But because you only need 2 points to graph a linear line, you can pick just these 2 points here, and voila, you got yourself a line. And we're going to go ahead and choose the blue equation and match the same orange line. Again, we're matching the line because it's the same equation. Same equation, same line, which means consistent and dependent. Okay, so remember, consistent and dependent is infinitely many solutions. Consistent and independent is one solution, and inconsistent means no solution. So we want infinitely many solutions, same line. All right, now they're changed up the equation, so it cannot be consistent and dependent no more because they're different. All right, let's go ahead and give this one a graph. We have y equals negative 3 over 2x minus 3. This one's ready to go. Start with the y-intercept of negative 3. So I'm going to go to negative 3 here. And the other negative 3 in the slope part is going to mean go down 3, 1, 2, 3. And to the right 2, 1, 2 lands right here. So now we're just going to go ahead and click on those 2 points to create the beautiful orange line there. All right, now we're going to get into our blue equation. We have y equals negative x minus 2. Now this equation is almost done for you, except negative x. Well, what does negative x mean for the slope? Well, negative x means negative 1x. But wait a minute, we need a fraction, so we got to add another one. So negative 1x over 1 subtract 2. All right, now we got our blue equation completely ready to go. So this is going to be nice. We're going to start with the y-intercept of negative 2. So I'm going to go down 1, go down 2 to negative 2 lands right there. It almost looks like it touched the orange line, but it didn't yet. We're going to go down 1 more, but to the right 1. So down 1 to the right 1 lands right here. And I'm going to do that a couple times to see what happens. Down 1, right 1, down 1, right 1, down 1, right 1. And notice it gets a little bit further and further away from the orange line. So if it gets a little bit further and further away from the orange line, what's going to happen is it's going to get closer and closer to the orange line as it goes up the other way. So I can pick any 2 points here. How about those 2? And notice they cross here at negative 2, 0 for the ordered pair. All right, so they cross one time. This is going to be a consistent and independent line. So consistent and independent. So they're consistent because they touch. Basically, consistent means touching. And independent means they are separate from each other. So turn that thing in. All right, here we go. We'll start with the orange equation first. So we got negative 1. So down 1, negative 1 lands right here on the y-intercept. And we have a negative 2 over 1. So down 2 over 1 for the slope here. So down 2, 1, 2, to the right 1 lands right here. And we're done. We're going to go ahead and connect those 2 points to create a line there. All right, next up we got negative 5, down 1, down 2, down 3, down 4, down 5. Negative 5 for the blue equation. And for the negative 2, that's going to be negative 2 over 1. So down 2 more, 1, 2 to the right 1 lands right here. And we're going to go ahead and generate that blue line as well. And if see how your point gets stuck on the orange line? When it does that, that's because you haven't selected the second equation yet. And now that I selected the second equation, it releases and lets me go ahead and graph. Now, take a look at our 2 lines here. The 2 lines are parallel and they don't cross. Because they're parallel and don't cross, automatically inconsistent. Consistent means cross. And dependent means they're the same line, and independent means they're separate lines. So this one, inconsistent, they're just 2 separate lines. They don't cross. They never will cross. They go round and round and round forever, and so forth. All right, this one here, they're being kind of sneaky. They use the same letters for variables and same numbers. However, they have mixed it around here. All right, now we got to figure out, well, how do we go about that? I'm going to start with the first equation. I'm going to show you two ways of doing it. Let's do the first way. The first way is you can do something called fix the equation. We have x minus y equals 3. Now, what happens here is I can subtract x from both sides to put the x on the other side. So this goes back to algebra. So now what happens is x's cancel out. We got negative y equals negative x first for the slope plus 3. Now see how it's looking more like a normal equation with y equals? Now what I don't want is the negative. I need it to be a positive. So what I'm going to do is I'm going to change all the signs to be the opposite. And how do I do that? Well, you can just simply divide both everything by negative 1. So negative divided negative is now a positive y. Negative x divided a negative 1 is a positive x. And positive 3 divide negative 1 is negative 3. So now look, we got a perfect equation here. Okay, that's one way of doing it. So I'm going to graph that, and I'm going to show you the other way of doing it where you can just find the intercepts. So the way this would works is you have down 1, down 2, down 3, negative 3, and x by itself is 1 over 1. You're coming good at that, right? Up 1 to the right 1 is there. All right, so we're going to graph that at negative 3 and that point there. Now, what about the other way? Is there an easier way to do this? Yeah, there actually is. It's up to you. Here's the other way. Let's say you have x minus y equals 3. What you can do is ignore one variable at a time to determine what the solution is. So for an example, the x, I don't care about it. So the question here is negative what equals positive 3? So negative what goes in the box equals 3. If I put in 3, that matches to 3, but I need the opposite of a negative to go positive. So negative and a negative is a positive. So what that means is I have a y equals negative 3. I'm going to put that aside there. Now, one more time, you have the equation. Let's just start fresh again. X minus y equals 3. We already figured out the y value. Well, what about the x value? Yeah. We don't care about the y value now. And actually, check this out. X is done for you. X equals positive 3. So how exactly does this work? Y equals negative 3. You can use that as a point on the graph. And I could plot it right there. And notice it's already done because we did it the other way already. And your second point is your x at positive 3, which we didn't do, but it's already crossing right there. And there it is right there. So you can get both points by finding something called the intercepts, or you can just fix the equation. Both work out really nice. It doesn't matter what you do. Just pick one. Hey, but for this tutorial, I did both, so that way you can see how that looks. All right. Blue equation is ready to go. So negative 3, the y-intercept, down negative 3, negative 1, negative 2, negative 3. Lands on that point. Y equals x. That's 1 over 1x, up 1 over right 1. Wait a minute, up 1 over right 1. It appears to be the same line in camouflage. So what they did is they jumbled up the blue equation to create the orange one, which is fine because I didn't fall for it. So now notice I'm stuck on the orange equation again. So I'm going to replot it. And to graph the blue equation, I'm going to go ahead and just click on the blue equation and graph the line right on top. Now, because of both the lines, they have infinitely many solutions, and that means they cross over and over and over again because it's the same line. It is going to be consistent, and it's also going to be dependent because dependent means they're also the same line. So consistent and dependent on this particular equation. That was a fantastic problem, which led us into a SMART score of 61. Let's clear off all of our hard work from the last equation and go from there. All right, blue equation first. Now, blue equation is x equals -1. No y value. Let's start with x equals -1. Literally, x equals -1. -1, -1, -1 lands. Okay, here's the x-axis. Find the -1, which is right here. Now, x equals -1 means a vertical line going straight up and down through x. Kind of like no slope, but it's the one that's undefined. Okay, so it's an undefined line. And same thing with the orange equation, it's also an undefined line. So to create an undefined line, because it's at x value only equals, we're going to go ahead and select x equals -1. And you can select anywhere going all the way up or going all the way straight down, as long as that line is straight up and down. As long as that line is straight up and down, you're going to be good. And we're going to go ahead and choose the orange equation, which is exactly the same as the blue equation, x equals -1. And again, just make the line go straight up and down. It doesn't matter which point you click on. Just make that line go straight up and down. All right, the line is consistent because they are touching and crossing over and over and over again, infinitely many solutions. And because they are crossing over and over again with infinitely many solutions, they're also dependent. So this one's going to be an infinite solutions. That's consistent and dependent. All right. Next up, we got another jumbled up equation and another regular equation. Let's see. Now the choice on the orange equation is, do we fix the equation or do we find the y-intercepts? On this one here, I'm just going to go ahead and find the y-intercepts. I'm going to find a y-intercept and an x-intercept. So let's do this. 2x plus 5y equals 10. I'm going to find the y value first. You can find either one first. It don't matter. I'm just used to find the y-intercept first. So I start with the y. So 2x, bleh, I don't care about. So the question here is 5 times what gives you 10? 5 times 2 equals 10. So the y value has to be 2. So again, the key here is 5 times what gives you 10? 5 times 2. So the y value has to be 2. All right, do a reset here. We got 2x plus 5y equals 10. Now, this time I want the x value, so I do not care about the y value. Blech. Get rid of that. So now the question is, 2 multiply what gives you 10? 2 times what gives you 10? Multiplication. Oh, if I remember, 2 times 5 equals 10. So therefore, x has to be equal 5 to make the equation true. And there we go. There are 2 points there. So on the y-axis here, find the 2, which is right here, because it says y has to be the 2. And on the x-axis, which is the horizontal axis, find where x is equal to 5, which has to be right here. And there we go. There's our 2 points. Once we got 2 points, that's all we need to graph a line. All right, time for the blue equation. All right, the blue equation, we got positive 2. So I'm going to go ahead and graph positive 2. And the slope means go down 2 to the right 5. Down 2, 1, 2 to the right 5. 1, 2, 3, 4, 5 lands right here. That's the same line again in camouflage where they just jumbled up. Well, it doesn't bother us because we're so smart, we know what we're doing. And look at this, I'm stuck on the orange line again. So I'm going to go ahead and reselect my orange line there. Then select the blue line. And now I can graph the blue line by clicking twice, one here and one here to create the line. All right, so they have to be consistent because it's the same line. And they're also dependent because they are the same line. Dependent is the same line. Independent means different line. So infinitely many solutions for that one. All right, smart score is 71, doing fabulous. We're going to start with our blue equation. So the blue equation, we got y equals negative x minus 3. This one's ready to go. We're going to start with negative 3, which is the y-intercept. So on the y-axis, I'm going to go down 3, down negative 1, down negative 2, down negative 3, which lands right there. And negative x, remember, negative x is the same thing as negative 1 over 1x. So down 1 to the right 1. So down 1 to the right 1 will give us our 2 points there. And that's going to create a beautiful blue line just like that. And notice that I bypassed it. You can do that. You can go up 1, left 1, up 1, left 1, up 1, left 1. And check it out. I'll still get it right because it's on the same line. All right, now y equals 0. Find the y-axis, go to 0, which lands right here in the middle. Now, because y equals 0, 0 is the y-intercept. Now, they didn't give you the slope. So what does the slope look like when it's completely missing? I'm not talking about partly there. I'm talking about completely missing because remember, there's no x value. Y equals 0 is the same thing as y equals no slope plus 0. A lot of zeros. Again, they left out the slope, so it's no slope, and the y-intercept, that 0 is that 0 there. So what you're going to do here for the orange equation is you're just going to make a horizontal flat line, like either like the ceiling, like the desk, like the floor, and that's it. So what do we got? We have consistent. They are crossing. Consistent means to cross, but they are also independent. Independent means they are two different lines. So we're looking for consistent and independent because they're going to cross one time. All right. We got ourselves two equations. Now notice they're both jumbled up. Doesn't bother me one bit because we can just unjumble it and actually use the y-intercept. So the y and x-intercept. Let's start with the orange side. We have x plus y equals negative 6. I don't care about the x value. Blah. Oh, check this out. Y equals negative 6 because there's nothing to multiply with the y. That one's already done. Now I need the x value, so I got x plus y equals negative 6. And now, because I'm solving for the x, I don't care about the y. Yeah, just get rid of it. Check this out. X literally is equal to negative 6. All right, so now what I'm going to do is I'm going to take those and find them on the respective axis. So y is negative 6, so here's my y-axis. Go down to negative 6, which lands right here. And my x is negative 6. Here's my x-axis. Find the negative 6, which is right here. And there we go. There's our 2 points to graph the orange equation. So click, and if I could get that right on, and there. All right, now the blue equation also needs some fixing up to do. So let's fix the blue equation. I got x minus y equals negative 4. First step, I'm going to solve for the y, which means I don't want the x. Blech, get rid of it. So now I have negative something equals positive 4. So I'm going to even put the positive sign in there. So now they're opposites. Be careful here. So rewrite that. I got negative something. I got to think of what goes in the box. Equals positive 4. It looks like 4 should match with 4. But in order to get this to be a positive 4, I need it to be a negative 4. Because a negative and a negative give you positive. But only what's in the box is negative 4, which means y has to be equal to negative 4. All right, I need an x value, so I need one more point. So one more point, let's do x minus y equals 4. This time I don't care about the y value. Blech. The negative goes with it because that's negative y. Wow, this one's already done for me because literally x equals positive 4 is left. So x equals positive 4. No thinking there. That one just came out nice. All right, let's go ahead and go on a hunt to go find them. So we got y equals -4. So I'm going to be on the y-axis looking for a -4. Down, down, down. Oh, careful. That's a +4. Down, 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 down. Lands -4 there. And x equals +4 is going to be over here. So that's going to land right there. So we're going to go ahead and connect them 2 points together. If I can get it connected. There we go. And there we go. We got it. So what is this? We have consistent. They cross. Consistent means they're crossing. And they are two separate lines, which means they are independent. Independent means it's separate. So consistent and independent is going to be our solution here because it's one solution. All right, last equation. Clear the screen. All right. Start with the purple equation. We need to fix it up. Purple equation. All right, let's do x plus y equals 3. On this one, I think I just want to rewrite the equation. What happens if we go the other way? Remember, I showed you both ways. So what if we do this? What if we subtract x from both sides? Because what happens is x cancels out, y equals, do your slope first, -x, then your y-intercept second, plus 3, and look at, now you got your equation. Y equals -x plus 3. That got it done. All right, start with the +3 on the y-axis, which lands right here. And now our slope of -1 over 1 will get us our next point. So down 1, right 1 lands right here. You can do it forever. Down 1, right 1, down 1, right 1, whatever. All right, so +3 lands right there. And down 1, right 1 lands there. So our purple equation is done. Green equation, I have x plus y equals -4. You know what? This almost looks exactly like the purple equation. If I just subtract the x, it's going to fix itself. So subtract x from both sides. X's cancel out. Y equals -x first because you want your slope first. Then your y-intercept of -4 comes second. So your final equation here is y equals -x, subtract 4. So the y-intercept is -4, so I'm going to go find on the y-axis a -4, which lands right here at -4. And a slope of -x means down 1 to the right 1, down 1, right 1, down 1, right 1. Ooh, looks like they might be parallel lines. Let's check and find out. Notice my cursor is locked on the purple line because I need to select the green equation first. So select -4, down 1, right 1. There we go. We got the lines there. So now we got two different lines. All right. They are not crossing, and when they don't cross, it's something called inconsistent. They don't cross. So the only one that's inconsistent is going to be that one, which represents a no solution. All right, that just took us to a smart score of 83. Thank you, and this concludes your fabulous IXL tutorial for CC6, classify a system of equations by graphing.